this doesn't show record. I mean, yeah, now it's recorded.
Yeah.
I can see it now. Right, thank you. Okay, so I'm sure I'll just quickly go this thing. Hello, message provider. As the business method, get message. This class's responsibility alone is to provide the message, the source of the message. All right. So this is more of a cohesion aspect. That this class is only sole responsibility is providing the message, which is hello world. Standard message renderer, who's responsible for dealing with how the message will be rendered, particularly coming from hello world message provider, considering that we have declared it as a member over here. The setter method takes the reference and assigns it to the local reference, and then inside the render method, we get the message and display it on the console. The launcher class is the class that holds all of these classes together. We instantiate the renderer, the provider, okay, and then we set the provider inside the renderer via the method set message provider. As you can see, this is the set message provider method. Okay, the reference of the provider is being supplied inside the renderer, and then when we call the mr.render method, we say message provider.get message, the message is obtained and the content is displayed on the console. So at this stage, we have achieved a slightly better decoupled code. I would not say it's completely decoupled because there are some situations, some problem scenarios, but this is the decoupled message renderer provider scenario. Mr. Hamid, I would like to have a confirmation from you that everything is okay so far. I hope you're understanding. Any confusion or any doubt with the flow of the program?
No, it's good, straightforward.
Okay, great. Any point of time you feel you are being confused, there's ambiguity, please point it out, or I'm going fast or slow, anything, please let me know. Okay, great. So now we have decoupled the areas. The provider is separate, the renderer is separate. Okay, we have a separate area that will pull these things together. Again, now we have another outstanding problem. What is this outstanding problem? When we say that when we make a change in one small area, it should not affect the surrounding areas. But if we intend to go from, let's say, hello world message provider to another provider called as goodbye world message provider, okay, when we do that, unfortunately, even though we are making a change inside the provider section, we are somehow affecting the renderer area. Okay, we are somehow affecting the renderer over here. The renderer gets affected, right? So hence, current problem scenario, we have not completely decoupled the provider. The provider, on the change of the provider, still the renderer is getting affected. Okay, so how should we deal with this problem? Current scenario problem points out clearly that the reference type basically is a concrete reference, and whenever the classes change, this class will also change to that reference type. So maybe if we could have used interfaces, things would have worked much better. So let's try to do that. Now we will have a message provider interface. Get message is the business method. Hello world message provider is the class that implements the message provider interface. Okay. Get message is the actual business method which is implemented here, which returns hello world. The problem that we have faced with the provider is certain to be faced similarly by renderer also. So we create the interface for the renderer as well, which has three important methods: the render method, the set message provider, the get message provider. Okay. Now, if you look at the standard out message renderer class, if you notice the change which is highlighted in the red color, the red font, we no longer have a concrete reference. Now we have an abstract reference. So today, and definitely we have the setter method over here, right? So today, if you are working with hello world message provider, a hello world message provider instance will be passed over here, right? And this reference will still point to the instance of the message provider, which in this case happens to be hello world message provider. If tomorrow the idea changes to move on to another provider, which is goodbye world message provider, in that case we simply have to pass the reference of the goodbye world message provider to the set message provider method, and the message provider reference over here will point to the instance of the goodbye world message provider, right? So the solution to the problem was the abstract reference. And now in our launcher class, we have the abstract references pointing to concrete instance, which is standard out message renderer, being pointed by the message renderer MR. Hello world message provider instance pointed by MP, right? So this is something that we have done. Now we pass the MP. What is MP? MP is basically a message provider, but in depth it is the hello world message provider. Hence, even though this line changes to goodbye world message provider, any part of the renderer will no longer be affected, right? Any part of the renderer will no longer be affected because we are using the abstract reference type. Is it clear so far?
Yes.
Okay, great, great. Because it's very important that we know from the beginning till the end what's happening. If you lose the idea anywhere in between, it will be slightly difficult to understand the later stages. Great. So now, yes, we can say that yes, we have achieved a very good decouple code, considering that the provider will no longer affect the renderer. We are very happy. But suddenly, out of the blue, we come to realize that unfortunately, the launcher class still is going to get affected. So even though I'm talking about using a new provider, right, and the renderer is very much safe, we get that part. But unfortunately, my launcher class, so-called hello world decoupled, is getting affected. It is getting hit. So how to deal with this problem? We can't keep on creating classes and providing references from them. Okay, that's a bad idea because eventually they will be again affected. So to deal with this problem, what we're going to do is we're going to create a simple factory class. Okay, what are we going to do? We're going to create a simple factory class. What this class will do, its sole purpose would be providing me the necessary instances. Okay, so let's have a look at it. Okay, so let's have a look at this class. Okay, message support factory class. Okay, I have the reference of the message renderer, message provider. Okay, I've intentionally created a static reference of the message support factory because I want to keep it singleton. All right. Also, the constructor, if you notice, it happens to be private. All right. Okay. And the properties is a Java class which basically reads the property file and creates a key value pair. Okay, I hope you know that context. Now focusing on the real code. What is the code over here? First, we load the properties via the file input stream inside the properties. We load msf.properties. Okay, let's quickly have a look at what msf.property is. This is the property file. Here I have mentioned renderer.class equal to standard out message renderer, provider.class equal to hello world message provider. Okay, that's what I've given inside the property file. Great. Moving further, the property file is loaded over here. Further, to get the value of the key renderer.class from the property file, I'm going to say props get property renderer.class. At this point of stage, I am holding a variable called as renderer class, which is basically holding the name of the renderer, which in this case happens to be standard out message renderer. Okay, so at this point, the variable renderer class has a value standard out message renderer, and the provider class variable has the value hello world message provider. Okay, just the names, nothing else. Further, I would say class.forName. I would pass the reference. Okay, I would pass the reference, and then I would say dot new instance. Right, I would say class.forName. I would pass the name of the class dot new instance. What would happen here is I would basically be instantiating, loading the instance. Okay, the JVM will load the instance. Okay, and give it to the reference renderer. So at this point of time, renderer, which happens to be a type of message renderer, points to standard out message renderer instance. Similarly, provider over here will point to an instance of hello world message provider. This part is slightly important because this is the real reason because of which we have created this entire factory class. Its sole purpose is to read the property file, create the key value pair, on the basis of the key provided, get the specified values. Once you get the values, which happens to be simply names of the classes, we instantiate them and apply it to our references. Okay, the references are given over here. Now, what we do in our launcher class, we say message support factory dot get instance dot get message renderer. What happens is when I say dot get instance, sorry, I had a bad throat. So now when I say get instance, what happens is I'm returning an instance which is of type what? Message support factory. So I have a static block basically. Okay, it's going to return me an instance of the static instance which is the message support factory. Okay, and it's a private constructor, so nobody can call this. It's a singleton behavior. So I get instance, and on that instance, when I call the get instance, basically by that time the constructor is executed. Okay, and these things get executed, and my message renderer gets populated. And all I have to do is simply say message support factory dot get instance dot get message renderer, which will give me the instance of the renderer, which is the hello world message standard out message renderer. Similarly, when I say message support factory dot get instance dot get message provider, okay, I am again getting the instance, right? After getting the instance, I call the get message provider, which is calling this method, which is a provider over here. This provider is basically pointing to the hello world message provider. At this point of stage, now we can say that yes, the code is pretty much decoupled. Why? The place of change is only limited to the property file. My Java classes are completely safe. They will no longer be changed. Is it clear so far? Any confusion?
Yes, is good, clear.
Clear how the factory is working, how the instances are getting populated? Okay, I'll take that as a yes. Now, let's moving further. The problem is that I mean, it's very cool to make a factory class. You can provide your implementation, make it singleton, but there are a lot of issues. Issues in terms of error handling, inheritance. A lot of things come into picture, and dealing with something like that is very problematic. So rather than creating something out of the wheel, we might as well simply depend on something which is existing. So what we're going to do is we are going to move to the Spring Frameworks factory class, which is called as the default listable bean factory class. This is actually the factory class which is running inside Spring right now. Okay. So let's look at the change. Okay, so what is the change? We have put that factory code in a method called as get Spring Bean Factory. Okay, and within that get Spring Bean Factory method, let's see what's happening. First, we will instantiate the factory. Okay, this is the Spring class. This is something that we have not made by saying new default listable bean factory. Then further, there is another class called as properties bean definition reader. Once again, this is a Spring class. We have not made it. We instantiated by passing a reference of the factory. Hence, whatever changes made to the RDR will be affecting the factory. Okay. Then, now, what I'm going to do, I am going to say properties. Okay. Props equal to new properties. Properties.load new file to stream beans.properties. This is the name of the property file. And okay, and I no longer do all that stuff that we did before. I simply say RDR.register bean definitions. What is RDR? It is properties bean definition reader. So register bean definitions is the method I'm calling. What does this thing do? Okay, the activities happening in this method register bean definitions is very much equivalent to the code which was being taken care over here. What we were doing manually before, we would manually read the class name, we would manually instantiate them, provided to the respective references. Right? Now what we are doing is, we are telling Spring to do it for us via the method register bean definitions. Okay, via the method register bean definitions. So register bean definitions understands that the grammar is somebody is asking for a key, give them the value and instantiate it. Okay. So that's the code of the default listable bean factory, having the properties bean definition reader, calling the register bean definitions method. Further, what do? Once we get the factory, On the factory, we will say factory.get bean renderer. So basically, again, it's going to read the property file for the key renderer.class, get the value, instantiate it, and return back the instance. So at this point, when this line of code is executed, MR over here is going to point to a concrete instance of standard out message renderer. Similarly, when I say factory.get bean provider, it's going to go read the property file, instantiate it, and handle me back an instance of hello world message provider, which is going to be pointed by MP. And eventually I have to set the message provider and call the render method. Okay. Is it clear till here? The only change we have done is we have moved from the custom made factory class to a standard factory class which Spring is using. Okay. And rather than we manually supplying the references over here, we have dynamic wherein we pass the reference and we get the instance. Are there any questions regarding this?
Okay. No.
Alright, great. Great. I'm really happy to see that things are moving smooth. And as I mentioned, any point of time you feel any issues, ambiguity, please let me know about it. Okay, so I mean, it feels very nice that we have now using we are now using a very sophisticated factory class that does a lot of things for us, right? Okay, so this is I mean, this at this point of time, yes, we can say that yes, we have achieved a completely decoupled. I mean, it looks very nice. That's nice. No effects on the any Java class. The property file is fancy. Right. Okay. Okay. Now the problem is that if you noticed in all the sessions, in the previous versions, we had of this hello world and the provider and the renderer. We constantly had to set the provider inside the renderer. Okay, we constantly had to set the provider inside the renderer. And I keep feeling that, you know, why am I doing this? I know very well that whenever I need the renderer, there should be some inbuilt mechanism that should give me the provider at that moment instantly. I should not be doing this line of code. Okay, when I say whatever I've said so far, it basically is pointing out to an aspect called as wiring. Okay, Spring acts at this point of time. Spring acts no more than a sophisticated factory class, creating and supplying instances of the classes as needed in this case. The startup code must have knowledge of the message renderer's dependencies and must obtain the dependencies and pass them to the message renderer, which is called wiring. You still have to inject an instance of the message provider into the implementation of the message renderer yourself. You're providing your own get bean factory method using low-level APIs of Spring framework. Now, at this point of time, we will introduce the concept of dependency injection. Okay, now we are going to introduce the concept of the dependency injection. By now, I'm sure you must have got the idea. What is dependency injection? Dependency injection is basically, okay, let's look at the solution first. Maybe then it would be nice to talk about it. All right, so let's make some changes. In the property file, initially we simply had these two lines. Renderer.class equal to standard.message renderer, provider.class equal to hello world message provider. That's all we had, right? Now we have added another line. Renderer.message provider ref equal to provider. Okay, we'll understand that. Another significant area, we no longer need to instantiate the provider. Note that you don't have to manually inject the message provider to message renderer anymore. It is because the message renderer object should be wired with the message provider object by Spring framework. Okay. Now, if you remember what we spoke a few seconds back, that the factory is created, the properties bean definition reader is created, and then there's a method, register bean definitions method. This is a very special method. What is it doing exactly? Let me help you understand that. When I say factory.getBean renderer, okay, it obviously is going to the property file, reading where the render.class is, and sees this is the key, right? And it realizes that yes, the class to be instantiated is standard out message renderer. But it doesn't stop there. It goes further to see that there is a line of code that says renderer.message provider, okay, ref equal to provider. And now I need your full attention and focus on this line, okay? What does this line mean? This line means that inside the renderer, okay, inside the renderer, there is a member called as message provider. Okay, inside the renderer, there is a member called as message provider with the capital P, as you can see. All right. There is a setter method for that member, set message provider. Now, as you know, a setter method will take in an argument and set to that member, right? So, what is that argument? The argument is a local reference. As you can see over here, the round brackets ref means it's a local reference. REF is the local reference. Now, the question is, which reference is this argument pointing to? The value of that reference is given by provider. Okay, the value of that reference is given by provider. Now, what is provider? Provider is another bean. Okay, provider is another bean. So basically, the total summation of this line is, it says that there is a member called as message provider. Call the setter method for that message provider and pass an local reference, which is a inside the argument, which is a provider. What is a provider? The provider is hello world message provider. So basically, from here it goes here, takes the instance, instantiate it, pass it inside the setter method of the message provider, and then return back the reference of the renderer, which in this case happens to be standard or message renderer. Whatever I spoke of, the way by which the syntax is read, the convention, it's all done because of this method, register bean definitions. It's because of the register bean definition, it understands that when I write this line of code in this format, it means set the message provider with the provider reference over here, and then return the bean of the renderer. And as you can see, because of that, the developer is no longer responsible for doing the wiring. Okay, the wiring is being taken care by Spring. The developer focuses on the business logic. What is the business logic? Calling the render method. That's it. As you can see, we no longer even need to instantiate the message provider. So, how is it? Does it make sense to you?
Yeah, just hold on to this code and just hold it.
Yeah, I knew that. I'm holding on to it. Let me know which part do you want me to go back.
Yeah, I think it's good, clear. You know, basically you're auto wiring that message renderer to it directly, right? The provider to it.
It is basically making sure. Yeah, it's basically making sure when the renderer is called, the member message provider should be populated. So,
Got it. And this all thing. No, I think it's good. This all thing is taken care by Spring directly. You don't have to do anything.
Exactly. So the focus is that as we travel from the property file, okay, then we moved on to the aspect of dependency injection. That's what Spring is doing for me. And lately, people, I mean, it's a very different format. The property file is not a very standard version, so people prefer to go on the XML format. So basically, we would be using the XML file, not the property file, okay? And the final version would look like this, where we have the bean, ID renderer, standard message renderer, okay? And there's another bean called as provider, hello world message provider. Inside the body of the bean renderer, we have another tag called as property. That property tag means that there is a member inside the standard message renderer class, which is message provider, okay? And a setter method needs to be called. The argument to be passed inside the setter method is a local reference, which is provider. Once you say provider, it will go and search for the bean with the ID provider. Instantiate the hello world message provider, set it in the setter method, and then return the renderer. Okay. And now, since we have moved on to that area, it's better that we use a standard convention of getting the factory, which is the constructor, class path XML application context beans.xml. Okay, we pass the
Can you go back to previous slide once again? Yeah, hold on. Okay, so here we are passing the property name as.
Yes, the property key name, which is a member inside the standard message renderer, which we have seen so far.
Yeah, you can proceed now.
Okay, great. So that is the XML format. The way by which we have tried to provide the dependency is called as the property injection. This format of dependency injection is called as the property injection. The reason being that we are trying to set a property. Oh, okay, that's the property injection. Okay, sorry, that moved really fast. Sorry about that. Another format of the injection is the constructor injection. Okay, and
The first one was property injection.
Yeah, the first one was property injection, and this one is called as the constructor injection, wherein we no longer use the property tag, we use the constructor arg tag. Okay, we use the tag which is constructor -arg, and we pass the value, which is basically a string over here. So basically, you might have either the ref or the value, either of these two things. I hope this part is clear.
Yeah.
Great, great, great. Now we are coming to the end of the session. Not exactly yet. A lot of things are still there. Whatever you have seen so far is all about the configuration. Okay. Lately, there has been a certain change in the school of thought that why depend on configuration? Why can't be there a standard convention? Why should we manually provide each and everything? Why should we do that? Considering a bigger project that has like hundreds of classes, is it really advisable that a person should actually go in the XML file and provide the entry of those 100 beans? Okay, that was the question raised. And because of that thought process happening, people have slowly moved towards the convention side. So let me introduce you to another aspect, which is called as the convention. Let's say that I do not wish to provide the injection through the beans. I'm going to use @autowire, which is an auto wiring. How does it work? First, the configuration. I have to declare a tag called as context : annotation config. Okay, that's necessary for the auto wiring part. Second, I no longer declare the property tag inside the renderer. Okay, as you had seen before, we had declared the property tag over here, right, inside the renderer, correct? But now I do not do that. Okay, I do not do that. Great. Secondly, I have added the auto wired annotation on the top of message provider. Let's go to our code again. Launcher esafe factory.get bean renderer. It comes inside the XML file, tries to find the bean with the ID renderer. It comes here, it realizes that yes, this is the bean. Let us start instantiating it. The standard message renderer starts getting instantiated, right? As it gets instantiated, as you know very well, the members of the class start to get default values. When it is doing that process of assigning default values, it realizes that this particular member, message provider, with a capital P, okay, and small m, is being applied the @autowire annotation. Now hear me properly, what I'm trying to say here. What does @autowire say? It says that go find one concrete implementation of the type of the member. I'll repeat. It says go find one concrete implementation type of the member inside the XML. First of all, what is the member? Message provider with a small m. What is the type of the member? Message provider with a capital M, right? So basically, what are we doing? We need to find one concrete implementation of the type message provider with a capital M. That is our purpose. Okay, where do we find it? It's going to find inside the XML file. So it's going to basically do a rough scan. I'm just giving you a hypothetical scenario. Okay, there's a lot of loading that happens, lazy and eager loading that happens at the JVM level. But I'm just giving you a hypothetical scenario. It kind of scans, okay, and it sees that okay, is this being a concrete implementation of message provider? No, it's not. This guy basically goes for renderer. Chuck it. move further. Is this bean a concrete implementation of message provider? Yes, because this class hello world message provider basically implements the message provider interface. Hence, it is a concrete implementation of this type. Purpose fulfilled, okay, match fulfilled. This bean will be instantiated and it will be linked to this reference of message provider with a small m. Are you getting it? How it has happened here? Or do you want me to repeat it?
And then no repetition required. I think I got it.
That's great. That's really great. So that's what auto wiring is doing for me. The dependency part is been taken care by added auto wire. Moving further. Also, as I mentioned before, that declaring all the beans is kind of hectic. So we move to another type of annotation which is called as component scan. Considering that we're using component scan, we really don't need to use the annotation config over here. Alright. And we simply say component. Now, what is this component scan about? The component scan tag basically says that the beans are not inside the XML file, but will be located in a package. We provide a package name. Okay, it basically means that go the bean inside that package, and hence it does that. So let us reiterate our scenario. Factory.get bean renderer. It comes to the XML file, searches for the bean with the ID renderer, and realizes that this is component scan. It has to search within the package. It goes inside the package. The first class it comes across is the standard.message renderer. Now when you're doing component scan, there are two things. One is the eligibility of the scan. Second is the purpose. To provide eligibility of the class, we need to have @component as an annotation provided on the class. So first eligibility. Is this class a eligible scan? Yes, it is eligible for the scan because @component is declared over there. First condition fulfilled. The class is eligible. Second, purpose. Why did I come over here? I came here for the bean with the ID or value renderer. It searches for the text renderer within the component annotation, either through this or it will search for the value attribute inside the component annotation. Once this match happens, it realizes and confirms that yes, this is the bean which is being asked for. Okay, our first step is complete. The bean is.
So what if we have two classes? What if you have two classes with the same structure?
Structure
in the sense same renderer and same value renderer like that. What will happen in that case?
Still not getting your point because.
See, for example, I have another class, public class standard out messages renderer 1, implement message renderer, entire body remains the same.
That's right. Correct. So again, it's your logic that you decide. Currently, I have decided that this particular bean is responsible, or rather is going to be reflected by the renderer key, the renderer bean ID. Tomorrow, if you feel that I need to work on out message renderer 1, okay, so you simply put the component annotation on the out message renderer 1 class, because you intend to use that bean, not this bean. Are you getting my point?
Yes, I got it. But by mistake say like component and that renderer remains same, the first line remains same. Will Spring take it, or it will throw some errors there?
It's going to throw an error because it expects the uniqueness of the beans via this text over. For example, the bean ID that we have, we can't have duplicate ones, right? We need to have unique ones. Similarly, it expects that the classes being annotated by other component or its stereotypes need to have unique values, right? So as I was saying, the benefit over here is that the getter call, the getter part, when I say factory.get bean renderer, that guy does not need to change at all. I have to not change that thing at all. All I have to do is simply move this renderer value to that so-called out message renderer 1. That's it. No change at all. Is it clear till here? Hello?
Yes, clear.
Hello? Okay, great. Moving further. Now what happens, the class is getting associated and great. Okay, I see there's a kind of a voice lag maybe. That's why we are slightly off track. Okay, moving further. We have a member, message provider. Once again, it's going to get a deep implementation. Once again, it realizes there's other auto wire. Once again, the rule comes into picture. Go find one concrete implementation of the type. It goes to the XML file. What is the type? Message provider. And it realizes that boom, no beans over here. It has to search within the package. It searches. Once again, the eligibility. Is this class eligible for scan? Yes, it is eligible for scan. Condition 1 fulfilled. Second, is this class a concrete implementation of the type message provider? No, it is not. Why? It implements message renderer. Chuck it. Move further. Second class, first condition, is this class eligible for scan? Yes, there is attribute component, hence it is very much eligible for scan. First thing. Second thing, is this class a concrete implementation of the message provider? Yes, it is. Why? Because this class implements the message provider interface. Hence, condition 2 fulfilled, purpose fulfilled, eligibility fulfilled. The class gets instantiated, the instance comes into picture and is linked to the message provider. This is the actual convention that now people have started going through. Okay, people have actually moved away completely from the configuration aspect and moved towards prominently towards the convention aspect, because they feel that the developer's assignment is more specific. He does not need to do the extra activities that he used to do before, and that's what Spring is doing as far as. It is implementing many design patterns, it is implementing many principles. At the end of the day, it just makes sure that the purpose of the business call is specific. And also, a lot of work has been reduced, as you can see very well. The beans declaration has completely been removed from here. So that's the reason, and that's the purpose of why Spring is being so lately famous and been helpful to developers. Any questions from your end?
No, I think I'm good. Got the idea.
That's great. That's great. So that's just the session of Spring we have. So this is how I take the session. This is the PDF which I will share with you later on. The example which has been discussed in this PDF will be given to you post the session so that you can have a look at it. Also, if the example needs to be explained, I share my screen and explain the flow. But again, in this case, there is nothing much to be explained because this is the actual example that we have tried to break and understand. But otherwise, I try to explain the program and show the flow, what the program is, what the configuration is. And we.
So this was the basic. This was the basic concept of Spring. Now, how many more classes we need to take to understand the full-fledged Spring?
Classes. Well, if I'm looking at 3 sessions. Sorry, 2 another sessions for dependency injection, wherein we'll be understanding the aspects of the application context. Okay, we'll try to understand what application context is and how beneficial it is. Annotations in terms of dependency injection, like @resource, @qualifier, @inject. Then moving from there, we will be talking about MVC. Another 3 sessions for MVC, wherein MVC 1 and 2 just basically talk about the how the mapping happens, what is the view resolver, request mapping, what are the attributes of the request mapping. Having said that, the 3rd session of MVC, we will be talking about the form handling, how the form is handled in MVC scenario, particularly the get, the reference data, command object, post, data finding, validation. We talk about Spring JDBC, how JDBC is useful in Spring, how it can be used. It's very similar to iBatters. After that, we have Spring AOP, then Spring Security. That's the plan of how we are going to go ahead.
So Spring Security, around 2 sessions for that should be enough?
Spring Security, 1 session I think should be sufficient.
Should be sufficient, okay. So approximately what we are looking is for...
Unless required, we can obviously take more if you have any concerns or needs more elaboration.
Okay. So okay. Now, so to best of your knowledge, you think another 2 sessions for this annotations and all those things. Then another 2 to 3 sessions for MVC, 1 for Spring JDBC, and 1 for security, right?
Yeah.
So probably 3, 6, 7. Another means if we do every day one within a week, we can wrap up the Spring, correct?
No, not in a week for sure. I mean, yeah, maybe for your case, yes, it would be a week. I mean, yes, you can obviously pull it off in a week, I guess. But I think so 2 weeks is what is a thing that happens with everyone.
Okay. Okay, that's fine. I think anything else you want to go through it today?
No, that was the basic version of helping you understand how the sessions are conducted, and just the preliminary session that talks about what Spring is all about. In the next coming sessions, we'll explore further dependency injection, the application context, and and that's how we'll take it ahead.
Okay.
Yeah.
Okay.
I'll be sending
No.
the PDF and examples later on.
Okay. You have my email address, or how would you send it?
I believe the coordinator
Okay.
with whom I'm meeting
I'll
will
send
be
every
giving
document.
the
Don't worry,
details.
Hamid. I'll be sending every document to you. I'll send the recording. I'll send the material shared by the Mr.
Okay.
Mudasar.
Okay. And who's this? Like so many people are calling. I don't know who's talking here.
Our team will be coordinating you very soon. My name is Manish, and we have a
Manish.
team. We
Okay.
have a team background lead, and everyone
Okay.
is being conducting a demo or something.
Okay, sounds good. So I think this is good. Can you arrange a call from somebody, maybe like Ganesh or Bala,
Ganesh, yeah,
because
Ganesh
this
will
was a
be
demo
coordinating.
class?
Yes, Mr. Hamid, Ganesh will be
Uh-huh.
coordinating you, or even I'll be coordinating with you guys. Maybe my teammates
So
will.
I just need to, yeah, what I need to do is I need to speak to them, finalize how we will go ahead with this.
Yes,
And I think this is
I'll.
just the basic string right now.
Uh-huh.
Yeah, and then from there we can decide the timings. What timings we'll have this class. We can finalize. Okay, Monday at this time, Tuesday at this time, something no class on Wednesday, something like that. We'll finalize the timetable, and from there we can
Yeah.
go ahead.
Correct.
So that way, we don't have to keep hanging, and one person is not there, this person is not. Let's not waste time, of each other. Time is important.
Okay, that's fine, Mr. Hamid. We will be suggesting you the training within a short and sweet time.
Okay, that's what I'm looking for, because I'm not going to go there and do each and every line of code. I need to understand. Now I understood what is auto wiring. I understood what is the dependency injection, at least at some level, so I can talk about it. My task at the end of this call should be I should be able to speak about it in the technical meetings and all.
We'll look after your requirement very soon, and Ganesh will be
Okay.
coordinating with about you about these points, and he'll be suggesting you everything.
Okay.
Okay.
Okay, sounds good. Thank you so much, and thank you so much, Mudassar, as well, for conducting the class.
Thank you. Thanks a lot. Thank you, Mr. Mudusa. Now, can I end up the session now?
Sure. Make sure that you don't record this and publish it anywhere, because otherwise my voice will go. A lot of people know me, here.
I'll definitely see to this. Okay.
Yeah, don't put it on YouTube,
We don't do this.